License Exams for Dummies, Part 5. You want how much? Valuation and Financing of Real Estate, Chapter 18, All of Their Numbers, Real Estate Mathematics. In this chapter, making the necessary conversions, measuring buildings and land, calculating percentage and commissions, finding out about mortgage numbers, seeing tax calculations and actions, wading through prorations problems, clarifying appreciation and depreciation, assessing appraised value. Chapter 18, All of Their Numbers, Real Estate Mathematics. Working in the real estate field is more than just selling real estate. It involves many skills and a thorough knowledge of many subjects, including math. As an agent, you may have to measure a room or a house, or calculate the taxes on a piece of property. And most importantly of all, you'll need to know how to calculate your commission. A quick note to all in the math phonics, you know who are real. Those of you who suffer from mathitis, or whatever you call it, should relax. Work through the material in this chapter and do your best. Above all, though, don't worry. The exam typically has few math problems. You do fine without necessarily getting a math equation right. Later on, as a friend likes to tell her mathematically challenged students, by the time you're in business a few months, you'll be able to calculate their commissions down to the last penny in their heads while waiting on the stoplight. In this chapter, I review some common math concepts and calculations. Notice I say review. You've already spent most of what is in this chapter in middle school and high school. You simply may not have seen it in real estate context. I show you how to apply some fairly simple math concepts to practical real estate problems. I'm sure you'll go through this chapter that is all will come back to you. Many students ask about rounding. The text writers are interested in knowing the basic formulas and techniques. They will give you questions where the difference between a right and wrong answer is a tenth of a number, and you might get it wrong due to rounding. Exam writers expect you to know the formulas involved in math calculations as well as how to actually do the calculations. You may run into questions that I call non-numbers math questions, where you may be asked to identify the correct formula to solve a problem without actually being asked to do the calculations. Be sure to memorize the formulas and to be comfortable with your calculators. Don't lose the faith, but you may have to convert. Before you start doing most of the math problems in this chapter, you need to remember that the test writers often throw problems at you that contain different units of measurement. In some problems, before you can solve the problem, you need to convert these measurements to make sure you multiply feet by feet, yards by yards, and so on. Also, you may have to calculate areas of the room in square feet, but later convert it to square yards. If any conversions are required to solve the problem, the exam writers won't give you the conversion factors. They expect you to know them. Memorize the following conversion factors to ease your problem solving. 1 foot equals 12 inches. 1 yard equals 3 feet. 1 mile equals 5,280 feet. 1 square yard equals 9 square feet. 3 feet by 3 feet. 1 acre equals 43,560 square feet. A section equals 1 square mile or 640 acres. A section equals 1 square mile or 640 acres. A section equals 5,280 feet, 1 mile on each side. 1 cubic yard equals 27 cubic feet, 3 feet by 3 feet by 3 feet. Landing building measuring areas and volume. Because you'll be selling land and buildings, knowing something about figuring out the size they are is important. For exam purposes, All you need to know is how to calculate the area and the volume of land and buildings after you have the measurements. Area is the amount of space on a flat surface. Calculating the area means figuring out how large a flat square is. It may be determined that the square footage of a house, the amount of carpeting or tiles needed to cover the floor of a room, or the amount of wallpaper needed to cover a wall. Remember, a wall still is a flat surface. How big is it really? Usually, land isn't something that you, as a real estate agent, measures. You may occasionally walk the boundaries of a piece of property and estimate its length and width. In general, however, if someone asks you the size of a piece of land, you'll look it up in the public records, like the deed, tax records, or public map filings, or you'll calculate it from information on a map drawn by the surveyor. Unless a piece of land is perfectly rectangular, square, or triangle, calculating the exact area of the property is difficult and best left to a surveyor. As an agent, you may have to measure a house or individual room. In general, overall house sizes start with the measurement of the outside walls of the house. If you need an individual room size, measure the actual room. However, due to the discrepancies in measurements over which buyers can get cranky, many agents now rely on public records when they advise the buyer on the size of the house. Volume is the measurement of what it takes to fill up something. In real estate terms, calculating the volume of a warehouse rather than just the floor area is important when you're informing a potential buyer about how much stackable space the property has. In this section, I'll take you through a series of examples that cover all the standard areas and volume calculations that you may encounter on a real estate exam. Calculating the area of a square or a rectangle. A square is a four-sided figure on which each side is the same length. A rectangle is a four-sided figure where two sides opposite each other are equal. For example, a rectangle may have two sides opposite each other that are 150 feet long, and two other sides opposite of it, which is 80 feet long. See figure 18-1 and 18-2 for examples of the square and a rectangle. Figure 18, square measuring 100 feet on all four sides, 100 feet by 100 feet by 100 feet. Figure 18-2, rectangular measurements, 150 feet by 80 feet. The formula for calculating the area of a square and a rectangular is the same. Length, L, by width, W, equals area, A. Like most other calculations in this chapter, when calculating area, the unit of measurement will be the same. You will have to multiply feet by feet, yards by yards, and so on. Furthermore, the answer to any area problem is always in square units. If you're multiplying feet by feet, your answer is square feet. You have a square piece of property that measures 100 feet by 100 feet. How big is the property? 100 feet by 100 feet equals 10,000 square feet. Or say you have a rectangular piece of property that measures 80 feet by 150 feet. What is your area? 150 feet by 80 feet equals 12,000 square feet. Notice the second question where I put the longer figures for length. It really doesn't matter in problem like this what you call each other. On a piece of land, the distance across the front of the property generally is referred to as the width, where the distance going from the street back is the length or the depth. Sometimes the problem may refer to the front foot or the front footage or the frontage, which usually is the same as the width of the property along the street. If you get the problem simply states two measurements of the lot, say 100 feet by 200 feet. Assume the first number is the measurement across the front of the lot, namely the footage or the width. Figuring out the area of a triangle. A triangle is a three-sided figure where all sides join together. Look up at the end of the peak roof house and you'll see a triangle. The triangle is called a gable end, and you may have to calculate the area to determine how much paint or siding is needed to cover it. The formula for the area of the triangle is a half base B times height equals area A. So you have, some of you have learned this equation as base B times height H divided by 2 equals area. Figure 18.3 shows the simple triangle. Figure 18.3 triangles with a base of 30 feet and a height of 12. Similar to the way you calculate the area of a square or a rectangle, when calculating a triangle area, don't forget that all of the units of measurement must be the same and the answer must be in square units. The height is the line that is perpendicular or in the right 90-degree angle to the base. Say you want to put your roof gauge in your roof gable end, and the width of the house at the point is 30 feet and the height of the gable is 12 feet. How much square feet are you going to have to paint? 0.05 times 30 times 12 equals 180 feet. Calculating the area of a circle. The circle essentially is a single line that curves around and meets itself. Pick up the quarter in your pocket and you've got a circle. The diameter is a straight line drawn through the center from one side of the circle to the other, and the radius is half of the diameter. The formula to find the area of a circle is pi times the radius r2, the square, the radius, you multiply the radius by itself. Pi is a constant number 3.1416. Check out figure 18-4 for example of a circle. Figure 18-4, circles with a diameter of 16 feet. Diameter of 18 feet, radius of 8 feet. Maybe you're going to build a round patio, or if you live in a farm country, you may have to rely on some of these calculations when determining the volume of a silo. When you're building a circular patio with a 16 feet diameter, what's the square feet of the patio block that you use? Pi 3.146 times 8 square equals A, area. Pi 3.1416 times 8 equals 201.06 square feet. Figuring out the area of an irregular shape. Unfortunately, houses aren't single squares or rectangulars, but rather a combination of several squares and rectangles. A rectangular house with a small breezeway, and an attached driveway or attached garage is a good example of what I'm talking about. And the key to calculating the area of a house like this is that you have to divide the figure into square and rectangles and occasionally even triangles. Calculate the area of each individual figure and then add them together. You're also pretty close to using this technique to calculate the area of an irregular piece of land. Determining the volume of almost anything. The formula for calculating the volume of any six-sided three-dimensional figure involves calculating the area and multiplying it by its height. Why six-sided? Most shapes that you have encountered in your real estate work will have six sides with opposite sides of equal dimensions. Think of a warehouse the example as follows, or a nice concrete patio in the backyard. The first part of the formula looks at what you're finding in the area of the flat surface. In the case of a volume, however, you also want to count the depth or the height of the structure, as the formula looks like. Length L times width W times height H equals volume V. Say you want to calculate the volume of a rectangular warehouse that measures 100 feet by 200 feet by 15 feet. The equation would look like this: 200 feet times 100 feet times 15 feet equals 300,000 cubic feet. Length times width is a formula for calculating the area, but by multiplying the answer, called the product, by the third dimension, the height, you get the volume. Just when you can't calculate the area, the measurements must also be the same units. With volume, the answer is always in cubic units. If all three measurements are in feet, the answer will be in cubic feet. In the case of triangular shapes, objects with the attic, in which the triangle height already is used to calculate the area, you multiply the area by the length of the attic. The whole formula is a half base B times the height times the length equals the volume. Finally, suppose you need to find the volume of a cylinder of a cylindrical object, like a silo on a farm. Once again, you will have to multiply the area of the silo base by the silo height. If you had a silo of 20 feet in diameter and 30 feet height, what is the volume? The radius times pi times the radius squared, r2 times the height equals the volume. So 3.1416 pi times 10 feet by 10 feet times 30 feet equals 9,424.8 cubic feet. Remember, the area of a circle involves the radius, which is half of the diameter. And that's why this example uses 10 feet instead of 20 feet. In case you have wondered about shapes and other figures, you're probably not likely have to deal with the volume of a octahedron, an 8-sided figure, or tetrahedron, a 10-sided, or some other unusual shape building. The preceding formulas should get you through the exam. For real estate career, and that the patios that you walk to a building in your backyard. Percentages. Pinpointing what you really need to know. Using percentages is another type of real estate math problem. Commission usually are figured on a percentage basis. Shared ownership of a property may be on a percentage basis. Vacancy rate usually are expressed in a percentage. You'll work with percentages to figure out the selling price of a property. Property tax equations may also involve percentages. So I think that you'll see the importance of understanding and be able to understand and answer exam questions about percentages. In this section, I provide the basics that you can apply to any problem asking you to use a calculator to calculate percentages. And by the way, I explain them to you as if you're doing these calculations by hand. Some calculators have percentages keys that you can use. Feel free to use them if you know how, or ignore them. A percentage, which is expressed as a number like 4%, 8%, 7.5%, or 0.8%, essentially describes what part of 100 you're talking about. The word percentage, or percent, comes from the Latin word centrum, meaning 100. So 4% means 4 parts per 100 of what you're talking about. If 4% of an eggs in a truckload are bad, then 4 out of every 100 eggs are bad. And if you're allowed to build on 4% of your land area, you can cover 4 square feet out of every 100 square feet with the building. The calculations you can do, the percentage usually are often multiplication and occasionally division, depending on the problem. You have 2 choices for turning a percentage into a number you can work with. You can either divide the percentage number by 100 or move the decimal point 2 places to the left. Say, for example, that you have used 7% in the problem. If you divide 7 by 100, you get the number that you can use the calculator or by hand. 7 divided by 100 equals 0.07. This isn't 0.07%. It's simply 0.07, which is the same as 7%. Another way of remembering is that the decimal point doesn't usually appear in a number, then it is assumed to be at the end. From there, the right side of a whole number. Move the decimal to the left 2 spaces, even if you have to add 1 or more zeros. 7% becomes 0.07. Check out a few more of these. 800%, 8. 80%, 0.80. 8%, 0.08. 0.8%, 0.008. 0.08%, 0.0008. 8.5%, 0.085. Note, you probably won't be working too much with small percentages such as 0.8% or 0.8% either on the exam or in real life. Don't forget, the reserve of this concept is so you can solve the problem like this. You make $20,000 commission on the sale of a $400,000 house. What is your commission rate? Keep in mind that the word rate usually means percentage. The calculation is 20,000 divided by 400,000 equals 0.05. Move the decimal point place to the right and your answer is 5%. Remember, to get from the decimal to a percentage, you move the decimal 2 places to the right or multiply it by 100. One other thing you need to know about is how to convert a fraction to a decimal and in turn a percentage. Don't worry, if you don't remember your 6th grade math class, this step isn't too difficult. Just divide the upper number, the numerator, by the lower number, the denominator. Doing so gives you a decimal. Now move the decimal point 2 places to the right. Don't forget to add a 0 as needed, and you have a percentage. Check out the following example. A half equals 1 divided by 2, which equals 0.5, which equals 50%. 3 divided by 8, 3/8 equals 3 divided by 8 equals 0.375, which equals 37.5%. 9/16 or equals 9 divided by 16, which equals 0.5625, which equals 56.25%. Commission. Tracking your moolah. You probably were wondering when I'll finally get to this all-important question, the amount you get paid. Discussing percentage is foremost because most commissions are based on the percentage of the sales price of the property. If you haven't read percentages pinpointing what you really need to know earlier in this chapter, take a few minutes to scan it before reading this section. In this section, I take you through a few variations of commission problems, including splitting the commission with other brokers and agents. I also have you look at how to get to a selling price working backwards from a commission, because the antitrust laws, which says that all commissions are negotiable and that brokers cannot agree among themselves price fixing to set certain commission rates. I make up all the figures that I use in the commission split in the examples that follow. For more about commissions and antitrust laws, check out Chapter 3. Figuring out how much you and everyone else earns. Here I start out with a couple of basic commission problems and then move on to commission splits. Figuring your commission. You're a broker who sells houses. The owner has agreed to pay you a 5% commission. How much will you earn on the sale? If a house sells for $400,000, the sales price times commission rate equals commission earned. 400,000 times 0.05 equals 20,000. Remember to turn 5% into a number you can use. In this case, 0.05 before you proceed with the rest of the problem. Figuring out your commission rate. A variation on the commission problem has you figuring out your commission rate. If you know the selling price of a property and the commission earned, to use the same numbers that I did in the last problem, you sell a listed house for $400,000. You earn $20,000 commission in sales. What is your commission rate? Commission earned divided by sales price equals commission rate. 20,000 divided by 400,000 equals 0.05 or 5%. Sharing the rewards. Commission splits. As a salesperson, your broker will pay you a share of the total commission earned for the sale. Remember that a salesperson works under the authority of a broker. See Chapter 3 for all full scoops. All commissions and commission splits are negotiable between the salesperson and the broker. A math problem, the splits may be expressed different ways. For example, a problem may have a 60-40 split, which means 60% going to one party and 40% going to the other party. Whenever the commission shares are unequal, the problem will be clear as to what percentage each party gets. Examples of these types of problems follows. Your firm receives $20,000 commission that is to be split 60-40 between you and your broker. How much will you receive? Commission amount times percentage share equals commission amount shared. 20,000 times 0.6 equals 12,000. Why did you use the 60 formula and not the 40? If you read the question carefully, the 60-40 split is the same order as you and your broker. If the problem doesn't give you any more information, you have to interpret that the test writers mean to scan the following problem, which contains more than one split. Suppose a $30,000 commission is earned on the sale of a house. The listing broker and the buyer's broker agree to split the commission evenly. The listing salesperson receives 40% of the listing side. How much will the listing salesperson receive? Where two brokers cooperate on a sale, they are often referred to as listing side. The broker who originally got the listing agreement to represent the seller, and the seller's side, the broker who finds the buyer in a particular question. You'll also have to know that splits evenly means that each of the sides get half of the total commission. So 30,000 times 0.5 equals 15,000. Listing and buyer side because the commission is split evenly. 15,000, the listing side commission, times 0.4, the listing salesperson share equals 6,000. Listing salesperson commission. A variation of this equation is using the same information, but also asks you the listing broker share. 100%, total percentage of the listing side commission, minus 40% of the salesperson commission equals 60% listing broker's percentage. 15,000 total listing side commission times 0.6. listing brokerage percentage equals 9,000 of the listing brokerage share. Determining how much a house should sell for based on the commission rate. Determining how much a house should sell for based on the commission rate. Establishing how much a house should sell for is an interesting calculation that has many users, primarily because it enables you to work backwards from a percentage to a number. But first, I have a problem that I want to try. Your seller wants the net take away from the closing table of $300,000. After paying your 6% commission, how much does the house have to sell for it to do this? The problem actually has two answers: $318,000 and $319,149 rounded. But one of the answers of $18,000 happens to be wrong. Now, before you start yelling and arguing or feeling bad that you got it wrong, allow me to explain. In virtually every math class that I teach, more than half of the class comes up with the wrong answer. But by the time you do a few problems like this one, by the time you do problems by this one, but by the time they do a few problems like this one that follows, nobody gets it wrong. Before I explain how you do the problem, I want to show you how to prove yourself that the $18,000 is wrong. This proof may come with handy on the exam to check your answer. Selling price times commission rate equals commission paid. $318,000 times 0.06 equals $19,081. Selling price minus commission paid, or the net to seller, $18,000 minus $18,80 equals $298,092. The number of $293.92 obviously isn't a 300 net the seller wants. If you got 318 for your answer, you just add a 6% commission to the net to the seller wanted. But it isn't actually how you calculate the selling price and commission. You get a commission by taking it away from the selling price, not by adding it to the net. If you get the same proof using 319, 149, you took 6% from the number. The owner gets the requested 300,000. Check the following examples if you need more clarification. What it is: the selling price, percentage 100,000, dollar amount X, that is what you're looking for. What it is: commission 6%, percentage. You don't know this is, you don't need to know. What it is: net the seller, percentage 34%, which equals 300,000. See, the commission percentage that the seller's net always equals 100% of what this is the selling price. If you know the dollar amount, that is the part of the larger dollar amount that you want to find, and you know the percentage of the total 100% that is represented, you can always find the larger number dollar amount by dividing the partial dollar amount by the percentage of the total that's represented. I'll say that again with numbers. 300,000 is the dollar amount that is the part of the larger dollar amount that you want to find. That is the seller's selling price. 300,000 is 94% of the larger dollar amount, which is 100%. By dividing 300,000 by 94, you get a larger number that is 100% of the total. 300,000 divided by 0.94 equals 319,194. In other words, if 300,000 is 94% of some number that you want to find, the selling price in that case, you have to divide the 300,000 by 94%, or 0.94, and you get 149. In this particular problem, you had to subtract 6% from the 100% to get the 94%, which is the seller's share. But the test writers may write the problem a little different, trying to trick you. You earn a commission of $18,000 which is 6% of the selling price. How much did the house sell for? Usually the logic of this kind of the problem, you'll reinstate it like this. 18,000 is 6% of some number. In this case, the number of the selling price. And if you know the dollar amount and the percentage of the whole number is represented, you have to divide it by the matching percentage. So 18,000 commission amount divided by 6% commission rate equals 300,000 selling price. So what is the moral of the story? When figuring out commissions in relation to how much a house should sell for, memorizing these two formulas. Net to seller divided by 100% minus commission rate equals selling price. Commission amount in dollars equals commission rate, which equals selling price. Making mortgage calculations without a fancy calculator. In this section, I do a few problems to review some of the math associated with mortgages. Chapter 15 has the scoop on mortgages and additional math, such as the problem involving loans and the value ratio. In these calculations, one important term to know is the amortized loan, which means that each payment on the mortgage is a combination of principal and interest, so that at the end of the mortgage terms, you have nothing left to pay. One of the questions I'm often asked is how necessary having a financial calculator is, either for real estate work or for the state exam. A financial calculator is helpful in making life easier for you to know how to use it. As for the state exam, a simple, inexpensive calculator does just fine. In fact, you can probably do most of the problems on your fingers and toes if you have enough of them. Calculating interest. A few standard problems that you have may find on exam deals with mortgage interest and principal payments. Here are the likely possibilities. Annual and monthly interest. All interest on a mortgage loan is expressed as an annual interest amount. So if your mortgage interest rate is 8%, that's the annual rate. Most mortgages are paid on a monthly basis, so that you sometimes need to calculate how much interest you actually paid in the month based on the annual rate. First, you look at the annual interest problem. You borrow $200,000 at 5% for 30 years at an amortized mortgage loan. How much interest will you pay the first year? Remember that a mortgage loan, the interest rate is always quoted annually and is always based on a loan unpaid balance. Loan amount times interest rate equals first year's interest. 200,000 times 0.05 equals 10,000. The first 30 years doesn't matter. It's extra information to confuse you. Now here's a monthly problem with different numbers. You borrowed $300,000 at 4% interest for 30 years in an amortized loan. What is the first month interest and loan? Loan amount times interest rate equals first year's interest. 300,000 times 0.04 equals 12,000 annual interest. You wind up with 12,000 for the first year's interest. Now figure out the first month's interest. All you have to do is to divide the first year's interest by 12. First year's interest divided by 12 equals first month's interest. 12,000 divided by 12 equals 1,000 first month's interest. Note that this annual interest calculation works this way only for the first month of interest. Test writers may go further and ask you to calculate the second month's interest. To answer the question, you need to know that the total monthly payment is, and the test writer will tell you. I'll continue to use the numbers from the previous problem. In this case, the monthly payment, which includes principal and interest, is $1,432 rounded. Information they have to give you. The question is, how much of the second month's interest payment? $1,432 rounded monthly payment minus 1,000 first month's interest equals 432 principal payment. A $300,000 loan amount minus 432 first month's principal payment equals $299,568 loan balance after first month's payment. So 200,099 loan balance after the first payment times 0.04 annual percent rate, which equals 11,982.7 interest owed for the next 12 months. 11,982.72 rounded to the interest owed for the next 12 months equals 12 months equals 998.56 interest paid for the first month of the 12-month period, which is in fact the second month of the loan terms. What you need to remember here is that an amortized loan, you only reduce the amount you owe by the amount of principal you pay each month, and not by the amount of the total payments, because each payment includes interest and principal. Total interest. A type of interest problem that seems to confuse people is the calculation in total interest. Total interest is the amount of interest you pay during the entire life of the loan, assuming you pay off the loan by making the payments within the required time frame. In general, banks provide these numbers to people, but you need to be familiar with the calculations because it's fair game on exam. Say you borrow $300,000 at 5% for 30 years in an amortized loan. Your monthly payments are $1,610 rounded. That is the total interest on the loan. Most people fool around with 5% for a while, but you don't need the percentage rate of a mortgage loan to work this problem. Watch this, because you're not going to believe how easy it is. 1,610 monthly payments times 12 months times 30 years equals 579 total payments during 579,600 total payments during the loan of 30 years. So 579 minus 300,000 original loan amount equals 279,600 interest during the course of the loan. Don't forget that every amortized loan payment contains part principal and part interest. That is the example in 30 years. You pay a total of $579.60 in principal and interest. So you will subtract the principal or the amount you borrow, and you're left with the interest. It's also a good determination of why you may want to pay your mortgage off as soon as possible. Figuring out monthly payments. Unless you use financial calculator, you're going to calculate mortgage payments using mortgage table. These tables, which are arranged according to the percentage of interest in the year of the mortgage terms, including the monthly payment to amortize or to pay off interest and principal for $1,000 mortgage loan. After you get the monthly payoff number, which includes sometimes the payment factor, you multiply it by the number of thousands of dollars in the mortgage loan, which you get by dividing the loan amount by 1,000. The factor for 20-year loan at 6% is $7.16. What is the monthly payment for a $150,000 loan? $150,000 divided by 1,000 equals 150 units of $1,000. 150 times 7.6 factors to pay off 1,000 equals 1,074 per month. If you run into a problem like this on exam, you either get a sample of a mortgage table or be given the payment factors that you need to solve the problem, and you remember the formulas in this example. In the real world, that is, when you have the license, you are working with your first million. Printed mortgage tables made any online mortgage calculation sites and financial calculators can make all of the relatively simple. All the pain of calculating taxes. If you want the lowdown on real estate taxes, check out chapter 16, where you'll also find a bit of math on equalization rates. In this section, I saw a few sample problems that you may encounter about taxes. You need to know this information not only for the test, but also because every listing of a property for sale generally requires an agent to find out what the taxes are. Calculating the assessed value of a property. Many municipalities use assessment ratios or assessed properties. An assessed ratio is the percentage relationship between the market value of a property, which is the amount the property will sell for on a normal market sale, and assessed value, which is assessed taxes assessors use to calculate taxes. It is usually related to the market value. I discussed the details of market value in Chapter 14 and assessment ratios in Chapter 16. The use of the assessment ratio creates the possibility of three kinds of exam problems. A property has a market value of $200,000. The assessed ratio is 60%. What is the assessed value? The market value times assessed ratio equals assessed value. So 200,000 times 0.6 equals 120,000. What is the assessed ratio of a property whose market value is 200,000 and whose assessed value is 120,000? Assessed market value. Assessed value divided by market value equals assessment ratio. 120,000 divided by 200,000 equals 0.6 or 60%. What is the market value of a property assessed at 60% assessment ratio? Assessed value of 120,000. Assessed value divided by the assessment ratio equals the market value. So 120,000 divided by 0.6 equals 200,000. Calculating taxes due. You can calculate taxes due using one of the following three methods depending on how municipalities calculate taxes and how much exam questions are asked. Mills. The method based the tax rate on so many tenths of a penny or mills and taxes for each dollar of assessed value. Dollars per hundred. This method based the tax rate on so many dollars of taxes for each $100 of assessed value. Dollars per thousands. This method based the tax rates on so many dollars of a tax rate per $1,000 of assessed value. You need to be familiar with the three methods for exam purposes. Mills. The tax rate in a town is 24 mills. The assessed value of a property is 30,000. What is the taxes of this? What is the taxes on this property? Assessed value times millage equals taxes owed. 300,000 times 0.024 equals 720. Remember that working with millage, move the decimal 3 spaces to the left because millage are tax rates expressed in mills or a tenth of a penny. Taxes per hundred. The tax rate is $2.40 per $100 assessed value. What is the taxes on a property assessed at $300,000? Assessed value times tax rate equals taxes owed. 30,000 times $2.40 divided by 100 equals taxes owed. So $2.40 tax rate divided by $100 ratio of assessed taxes equals 0.024 tax rate per dollars of assessed valuation. So 30,000 times 0.024 cents equals $720. Taxes per thousand. A tax rate on a property assessed at $30,000 is $24 per thousand. What is the taxes? Assessed value times tax rate equals taxes owed. 30,000 times $24 divided by $1,000 equals taxes owed. $24 tax rate divided by $1,000 ratio of assessed value equals 0.024 tax rate per dollars in assessed valuation. So 30,000 times $0.024 equals $720. If it's easier for you to see, you can also divide the assessed value by the unit in which the taxes is stated. In this case, you could do the following: 30,000 divided by 100,000 30,000 divided by 1,000 equals 30 units of 1,000. So 30 times 24 tax rate per 1,000 equals 720. If the tax rate is stated per 1,000, then divided by 100 instead of 1,000. Putting proportion into perspective. Proportion is the allocation or dividing a certain money items at the closing. I discussed proportion in closing in more detail in Chapter 9. An attorney, a real estate salesperson, a broker, or a representative of a title company does the proration calculation at the closing. In any case, most test writers expect you to know the basics of proration math. The key to remember about prorations is that the person who uses is needed to pay for it. Here's an example that illustrates the point of proportion. The seller has paid taxes of $3,000 for the entire year ahead of January 1st and sells his property and closes title on June 1st. Who owes what to whom? The seller paid the full year's taxes, but uses the property only for the first 5 months, January through May. Read the problem carefully. The buyer needs to pay the seller for the taxes already paid for the month the seller won't own the property during the year. The rest is just the math of dividing up who pays into who pays. Who paid and who pays. 3,000 divided by 12 months equals 250 per month. 250 per month times 5 months, the time the seller owned the property, equals 1,250. This is the amount of taxes that the seller used from January through May. So 250,000. So 250 per month times 7 months, the new buyer time in the house equals 1,750. This is the amount of taxes the buyer will use because he bought the house on June 1st. Because the seller already has paid the taxes for the whole year, the buyer owes the seller 1,750 for the taxes that the buyer will be using and didn't pay for. The terminology of proration, the buyer gets the debt and the seller gets the credit. Here's another problem with that the buyer pays in arrears or after the fact. A buyer pays $2,400 in taxes in arrears for the entire year on December 30th. He bought the house on September 1st. Who owes what to whom? So 2,400 divided by 12 equals 200 per month. 200 per month times 8 months, the time the seller owned the house, equals 1,600. The seller used 1,600 of paid taxes. Now, to determine how much the seller didn't use, 200 per month times 4 months, the time the buyer owned the property, is 800. Because the buyer paid the full 2,400 for the previous year, which he owned the house for only 4 months, the seller owes the buyer 1,600. The buyer gets the credit and the seller gets the debit. When you get into the real world, find out the local practices is for dividing up a year of probations. Some areas and attorneys use the exact day rather than the month, so that the previous example divided by 365 days to get the amount of taxes paid per day. Some people use 12-month annual calculation and then divide by the exact number of days in the month. And when the closing date occurs mid-month, as far as I know, no state law governs this practice, but rather it's a matter of local practices. On the exam, the test writer usually specifies actual days if they want you to calculate it that way. If the time frame isn't specific or you're instructed to otherwise on the exam, you need to use a third method, which is divided a year cost or payments by 12 and the monthly by the number by 30, unless the real estate course or textbook specifies that the other method is the only method used in the state. The state-specific items can affect prorations is owned by the property on the day of closing. Unless your state says otherwise, assume that the buyer owns the property on the closing date. I'll do the other state-specific items that can affect proration rates is who owns the property on the day of closing. Unless the state says otherwise, assume that the buyer owns the house on the date of closing. I do a problem with the mid-month closing date to illustrate a 12-month by 30-day method. As owner sells the house and closes on May 17th, but paid a full year's taxes of $3,600 in advance on January 1st. What is the proration of taxes? $3,600 divided by 12 months equals $300 per month. 300 divided by 30 days equals $10 per day. The seller owned the house for 4 full months, January through April, and 60 days in May. Remember, the buyer is considered the owner of the house on the day of closing. 4 months times 300 per month equals 1,200. 16 days times $10 a day equals $160. So 1,200 plus 160 equals 1,360 taxes used by the seller. 3,000 and 6,000. 3,600 total taxes for the year paid by the seller minus 1,360 taxes used by the seller minus the equal to 2,240 taxes used by the buyer. The buyer owes the seller 2,240. The buyer gets a debit of 2,240, and the seller gets a credit of 2,240. Appreciating, appreciation, and depreciation. As if you were confused enough already, you'll find that only kind of appreciation, but there are 2 kinds of depreciation. Stay with me though, because the stuff really is pretty easy. Appreciation is the increase in the property value caused by factors like inflation, increasing demand, improvement on the property. Depreciation is a decrease in the value of the property caused by lower demand, deflation in the economy, deterioration, or the influence of other undesirable factors like a new sewage treatment plant going in next door. Another type of depreciation, which I discussed in chapter 17, is a tax benefit the government gives people on real estate investments. Real estate salespeople and brokers, buyers and sellers always are interested in how much a property value has increased or decreased. Investors, real estate brokers, and salespeople may want to know what tax benefits of a property are attributed to depreciation. Although more often than not, the accountant needs to be doing these calculations for the investor. Test writers expect you to know the basics of how to calculate appreciation and depreciation. Getting more or less appreciation and depreciation of a property's value. People always are interested in how much or more they can sell their property for than what they pay for it. They may not want to consider a loss to their property's value, but they can happen too. A real estate agent is expected to be able to track increases and decreases in the property's value and to apply market increases to specific properties. So if getting more or less appreciation and depreciation of a property value, people always are interested in how much more they can sell their property for than what they pay for it. They may not want to consider a loss on their property's value, but it can happen too. A real estate agent is expected to be able to track increases and decreases in property value and to apply market increases to specific properties. So if overall the real estate market valuation in the area is increased by 10% during the last year according to the government or other statistics, you need to be able to apply this increase in value to a specific property. By the way, not only market values can increase, any of these type of values that I discussed in chapter 14 can increase or decrease. I show you how some math on how to handle these problems in the real world and on an exam. You bought a house for $200,000, and 5 years later you sold it for $250,000. What is the rate at which the house appreciated? The formula for this type of problem has two parts: the new value minus the old value, change in value. Change in value divided by old value is the percentage of change in value. So 250,000 minus 200,000 equals 50,000. 50,000 divided by 200,000 equals 0.25 or 25%. A different type of problem deals with the decrease in value. You bought a house for $200,000 and 5 years later sold it for $150,000. But what percentage did it depreciate? The formula for this type of problem also has two parts: the old value minus the new value, the change in value. The change in value divided by old value, the percentage of change. So 200,000 minus 150,000 equals 50,000. 50,000 divided by 200,000 equals 0.25%. In either of these problems, you divide the change by the old value. Keep an eye on whether the test writers ask you whether the problem preceding question using the word change rather than appreciate or depreciate. For example, by what percentage did the value of the house change? In that case, the answer will have either a plus or a minus sign in front of them. The appreciation answer would be plus 25%, and the depreciation answer would be minus 25%. Now for a reverse problem. A house sold for $260,000, which is 130% of what you paid for it. How much did you pay for it? The formula for this type of problem is current price or value divided by percent of original price equals price or value sought. Notice in the formula that I say percentage of original value, which is always 100%, plus the change, which is plus 30%. Now, did you know this? Since the numbers are not given that way, read the wording of the question carefully. It said that the house sold for 130% of the original price, not 130% more than the original price. Another way of looking at it is to say 260,000 is 130% of some number. In this case, the original price, if you can't say it that way, you know to divide the dollar amount you were given by the percentage number. Well, the number of problems look like this: 260,000 divided by 1.3 equals 200,000. 1.3 is decimal equivalent to 130%. Another similar to the reverse of the question. You bought a house for $300,000, which is 75% of what you're selling it for 5 years later. What price did you sell it for? The original price or value divided by the percent of selling price equals the price or value sought. 300,000 divided by 0.75 equals 400,000. Once again, you'll say 300,000 is 75% of some number. In these type of problems, you can usually get the number you're looking for by dividing the number you're giving by the percentage that it represents. You can find a similar problem in section on determining how much a house should sell for based on the commission rate early in this chapter. Depreciation, the government kind. In chapter 17, I explained the concept of depreciation, and sometimes I call it cost recovery. Although in the real world, accountants working for real estate investors usually do these calculations. Test writers expect you to understand and to be able to apply the basics. This type of depreciation has nothing to do with the property going down in value, but rather is based on government regulations that is designated to help real estate investors reduce their tax burden. You have a building worth $250,000. You're allowed to depreciate it over a period of 27.5 years, also called the cost recovery period. What is the annual amount of depreciation? The cost of the property divided by the cost recovery period, the annual amount of depreciation. So 250,000 divided by 27.5 equals 9,090.91 cents. Now suppose you were asked about the annual rate of depreciation is. You need to know the dollar amount to figure that out. You need only the cost recovery period. You are allowed to depreciate a building over a period of 39 years. What is the annual rate of depreciation? 1 divided by 39 equals 0.0256, which equals 2.56% per year. Or you can also divide 100 by 39. 100 divided by 39 equals 2.56% per year. Try it both ways on your calculator to see if you get a little practice with decimals and percentages. Estimating appraised value. If you want the lowdown on appraising properties, check out chapter 14. As a real estate agent, you won't actually be doing appraisals, but you can use these formulas to roughly estimate property values, particularly if you deal with investment properties. You can read about real estate investment in chapter 17. But in the meantime, state test writers expect you to understand and to be able to apply these formulas. In this section, the only real math-driven formulas for appraising, at least at the level that you're expected to know, is the formulas for finding value using the income approach. Two different methods are used in approach the value. I give you the formulas and examples for both. The capitalization method. The capitalization method uses one formula for finding a property value, and with a couple of variations, you can find property income and capitalization rates. Capitalization is a technique for estimating the property value based on its income. You can read all about it in chapter 14. The formulas used as the following symbols. I equals income or net operating income. R, which equals the rate of return or capitalization rate. And V, the value or the sale price. Don't be confused by the possibility that any of these letters can mean two different things, such as the income versus net operating income. Memorize these terms and the problems will be clear as to what you're being asked. Also, remember that these problems all numbers are based on annual figures. So if, for example, you're getting a monthly income number, you need to multiply it by 12. The formulas are as follows. V equals I divided by R. I equals V times R. R equals I divided by V. In the following three examples, I use the same numbers to illustrate how these formulas work. Find the value of a building that has a net operating income of $30,000 with a capitalization rate at 10%. V equals 30,000 divided by 0.1, which equals V equals 300,000. Find the income of a building that was sold for 300,000 where the rate of return is 10%. I equals 300,000 times 0.1 equals I equals 30,000. Find the capitalization rate of a building that sold for 300,000 that has a net operating income of 30,000. Revenue equals 30,000 divided by 300,000. R equals 0.1 or 10%. The gross rent multiplier method. The method for finding the value of a property using the gross rent is the easy matter of multiplication. The gross rent multiplier is used to estimate the value of a small investment minus type of properties like small multiple family houses. You can find out more about it in chapter 14. The formula is value equals gross monthly rent times gross multiplier, GRM. The variation of these equations are GRM equals sales price or value divided by rent. Rent equals sales price or value divided by GRM. The following examples show you how to use these formulas with numbers. You're appraising a building that generates a gross monthly rent of $3,000. You've calculated it to GRM of 100. What is the value of the building? The value equals 3,000 times 100. Value equals 300,000. You're trying to calculate the GRM using information on a building that's recently sold for 300,000 with a gross monthly rent of 3,000. Find the GRM. The GRM equals 300,000 divided by 3,000, which equals 100. You would rarely have to calculate the rent using the GRM formula, but just in case, here's the last example. Say you're looking for a building to invest in that's selling for 300,000 with the GRM of 100. What is the annual gross rent income? Rent equals 300,000 divided by 100. Rent equals 3,000. Don't forget to note whether the numbers are given based on the monthly rent or the annual rent, and whether the question involves a gross rent multiplier, GRM, or gross income multiplier, GIM. GRM uses monthly rent numbers and GIM uses annual rent numbers. You may have to convert one of the others to use the numbers given. And just to make your life more interesting and confusing, I have seen GRMs sometimes calculated on an annual basis, and the GRMs involving deductions of expenses. I doubt your course or your exam will get that deep into the whole subject, but you should clarify and make sure you understand the terminology used in exam. And that was for part 5. You want how much? Valuation and financing of real estate. Chapter 18. All of the numbers. Real estate mathematics. Thank you very much.